Welcome, welcome. Happy International Women's Month, everybody. So thankful for y'all tuning in. It's been a lovely month so far. We've had a lot of power pack speakers. We had a lot of great events, and we want to continue to deliver that. And y'all in for a special treat today. So I just want to welcome you all. This is the third talk that we had of the month, and I just can't wait to see how y'all feel about it afterwards. So make some noise in the chat. Let us know where you're tuning in from. Super excited to introduce today's guest speaker. Selen is a passionate and skilled Android developer at Akbank, one of the largest banks in Turkey. She holds a bachelor's in engineering and in computer engineering. She has experience in developing and maintaining Android applications and using Kotlin and Java, as well as working with Spring Boot framework for backend development. She is currently now doing her MBA in Kennedy University. So we want to make sure that we give our warm guests our great guest one of the warmest welcome. Everyone, I'm bringing her to the stage. Hey, Selen, how you doing?
Hello, everyone. I'm good, thank you. How are you?
I'm doing well. I'm doing well. How's everything? How's your morning going?
It is good. It is not here.
Oh, well, I should say, how's your evening or day going?
It was good. Thank you so much.
Well, thank you. But the people didn't come to hear or see my lovely face. They're actually here for you. So, you know, you're in for a great talk. I can't wait to see your reaction to it. But I'm gonna take myself off stage and Selen, the stage is yours.
Thank you so much. So I will share my screen right now. Hello, Chanel. So just sharing my screen. Mm, 1 second. Yes. Please let me know in the chat if you can see my screen. Amazing. So thank you. Thank you, everyone. So today we will have a little jam-packed session. So I am afraid that we will not have time for the questions in that because I added some slides after I finished the presentation. So because I wanted to give you a little bit information about animation too. So that's why you can add me on LinkedIn. I will definitely add everybody there and ask me your questions there. I will answer every question you ask through my DMs. So let's get started. So Dam already introduced me, but I will also introduce myself quickly. My name is Selen. I am an Android developer and I live in Turkey. I'm a Women Tech Maker Ambassador and Digital Education and Literacy Director for Women in Tech Netherlands. I also have like a newsletter in LinkedIn. I wrote about like space and tech news. I am doing my MBA as a space MBA, which is focusing on space leadership courses too. So that's why I wrote about space and tech. So make sure to follow my newsletter too. So today I will talk about Jetpack Compose. Since our time is limited, I will focus mostly on like layouts in Jetpack Compose heavily. So this will be an introduction to Jetpack Compose. So if you know Jetpack Compose, you will definitely find some valuable informations with the animations too. But if you don't know anything about Jetpack Compose, this will be it for you. So let's get started with a quick like a quote from like the Android co-founder um, Andrew Rubin. So Android is the mobile platform open for everyone. It is what we call democratization of technology. So anyone can be developer, anyone can contribute. This openness is our biggest strength. So that is why I love Android so much. So as of table of contents, we will talk about what Jetpack Compose is. So what the composable functions are, layouts in Compose, which will be talked about heavily, and I will show some code snippets. And after that, I added this newly animations and transitions. We will talk about a little bit about that, and I will share two examples, and we will go in depth with two examples. And lastly, we will touch up on a little bit about like what is material design in Compose and how we can use material design in Compose. So let's get started. What does Jetpack Compose is? So before Jetpack Compose, like we were building UIs with XMLs, with like views, like button, text, etc. But now we have a more modern approach, which is similar to Swift UI. So if you use Swift UI before, it is like exactly the same thing with Jetpack Compose, in my opinion. So since Jetpack Compose is a declarative UI framework, rather than instructing it on how to display content, developers define like what their UI should look like. So we have some advantages of using Jetpack Compose in our projects. So the first one is it definitely reduces the code. So Compose employs a declarative methodology, which helps us to provide the desired appearance of your user interface, and Compose handles the rest. So compared to standard Android UI development, we will do like with the XMLs and view objects. So this leads to a considerable reduction in code size. So Compose is straightforward to understand and use, like especially for Kotlin developers, since it makes use of well-known Kotlin syntax and ideas. And nowadays, like we use mostly Kotlin with Android too. So it is a bonus advantage. So Compose has a strong feature and tool set that includes like animation, state management, and custom components. We will talk about it today. So Compose can help you like create your user interface more quickly and effectively because it is declarative and it requires less code, which enables us to have a dynamic content too. So I took the states from the Google's website. So this is like a really great example about like how Compose is useful. So Dropbox engineers said that they rewrote their search experience in Compose in just a few weeks, which was 40% less time than anticipated and less than half the time it took the team to build the feature on iOS. So they also share that they were interested in adopting Compose because of its feature of like its first class support for design system and tooling support. On the other hand, Google Drive team cut their development time nearly in half, like when using Compose, combined with, of course, architecture improvements. It is definitely a great start and great things to learn. So let's get started to understand our core concept, like the composable functions, which is the core concept of Jetpack Compose. So when you make true your compose variable in your app build Gradle file and sync after that, you can use compose in your Android Studio. But if you have the newer versions of Android Studio, when you choose the empty activity, it will automatically open as a this activity. So let's take a look at it in detail, like what this all means when you see this code block. What should you understand from it? So first we'll see like the main activity part, which we all know, and inside of it we will see a set content function, which is same as XML. We use this as set content view. So inside of the set content lambda, we will define the composable functions inside of it. So this part is all about what we see in the app, like when we run the code, what we see it in the emulator. So inside of this, we have something called a scaffold layout. So, which is a layout that provides a basic structure for an app screen, like including a top bar, bottom bar, and content area. So, the scaffold composables takes a modifier argument, which is used to specify the layout parameters for the scaffold. So, in this case, it took like the modifier for max size, is used to make the scaffold fill the entire available space. We will talk about the max size in the other slides too. So this fill max size will help us to just fill out all the available space in the screen. So the scaffold composables also takes a lambda argument, as we can see it in the screen, so which is used to specify the content of the scaffold. So the lambda argument receives the inner padding parameter, which represents the padding that is applied to the content area of the scaffold. So this padding is necessary to ensure that like the content does not overlap with the top bar or the bottom bar. So let's take a look at an other part of the generated code block. So that was the first part, and this is the second auto-generated code. Let's understand it a bit more. So in the greeting function, as you can see in the screen, so we have something called text, which is equivalent to text driven XML. So the other thing is with the Jetpack Compose, we have something called a preview annotation. So when you just do the preview annotation, which helps you to preview your function results on time in your screen. So you don't have to like run the code to see it. So in the first part, this part helps you to like in the on create, when you make changes, you can see those changes when you run the code. But when you do some changes in the preview, in the function here, like the greetings preview, you can instantly see those changes in your screen in this preview side of the screen. So how it is working, like how we can do this. So with the preview functions, the important thing is that like the preview functions are not taking any parameters. So that's why we are creating something called a greeting preview, like an empty function. And after that, we are calling our main function inside of that preview function to see it in the preview window. Because this is a rule that like the greetings preview, any preview annotation function is not taking any thing inside of it. So that's why we are creating an empty function and empty composable function. And after that, we're adding the preview annotation and calling our main function inside of it with our desired parameter. So in this way, we are now can see like instantly the changes in the screen. This way, we are calling the hello with Android, and we are seeing the hello Android. And now here we are calling with Selen, and we can see it easily, instantly as hello Selen in the screen. So this is definitely a cool thing with the Jetpack Compose, the preview annotation and the preview part of this. So definitely take a look at it in depth more. So let's take a little bit about like how we are just like, what does this all mean? So let's take a look at it. In the greetings function, we have something called text. And as I said it before, it's the same as text view in the XML. So in the text view, you can see like which parameters it can took, like hit control or like command P, and see like what parameters the text can took. So as an example, I gave it a couple of them to show you like what we can give, like a font size, color, background color, font style, font weight, etc. But the most important one we can give is a modifier here, like the different thing with the Jetpack Compose, which is like a specific style for our UIs inside the modifier. So this was definitely interesting to me when I was experimenting with Jetpack Compose, because inside the modifier, like I first add padding, as we can see it in the screen, and after that, it adds some like space the other corners, and we can give like border, clickable size, and clip. And here I also use clip to circle the corners, as you can see it in the screen. Because of the color, it is not really looking great, but I just like clip the corners too. So I did that with the clip function in this modifier. So the important thing is like with modifiers, it matters like what order modifier functions are in. So in the order matters because since every function modifies the modifier that was returned by the function before. So let me explain. So the background color is only applies for the space we add the padding, like it is our starting point. And it is also same with the clip. So there is a lot of things you can do with the modifiers. You can change the order, you can add a lot of like other modifier functions to it. So definitely I recommend you to create a basic file to just like experiment and understand a little bit more like how really modifiers work. So let's continue. So we learned how to create a text, but now we want to display two texts in a row. So how we can do that? We can use layouts for that. So we have a couple of new layouts and old ones too. The first one is box, which is new, and row, column, lazy layouts, flow layouts, constraint layouts. We have those layouts, and we will go over all of them today. So let's start with box. This is a really interesting one. And I believe, like for the Jetpack Compose, this is also an important one too, because box layout can give us a lot of like flexibility. So box layout is equivalent to frame layout in XML. So within Jetpack Compose, like box is an essential component because it helps us to create like really great user interfaces. So think of a box like container, like a canvas that allows you to like arrange other modular components in different ways by stacking them and positioning them. And box allows for a greater placement flexibility. That's why it is really a cool thing to have. So like rather than a column and row, it offers the flexibility, like placement flexibility, which is really cool. So we organize their content in a predetermined sequence. So in Box, you can place any number of composable functions, meaning elements are stacked upon each other. So you can use modifiers like align, offset, and size to adjust the position and size of the each child composables inside of the box. And also you can clip the overflowing content of child composables to the boundaries of the box. So you can set a background color or image for box to enhance the visual hierarchy too. Let's take a look at an example. So box is a composable element, like a text, and you can see it in the screen that we just like implemented here, like a text, and added a modifier here, and set the background color to green, as we can see it in this preview window. So after that, we have something called like inside the box, we just in the box scope, we added the image and icon, which like we added the image first and we added the icon on top of it. So box stacks upon the elements. So both of them have like content descriptions in image and icon, which is similar like text. We can integrate it, the image and icon, however we want, and we can also position them too in box. So we just like stack upon each other today in here, and we have something called a painter, which will give our like the icon resource name in here, and we can give the content description. But if you don't want to give it, you can give it null. So in icons, we are also give our icon name and content description again. You can send it null. And we can give icons a color, which I set it to magenta here. And you can see our celebration icon is a magenta. So it is really a cool thing to give like icons on the code, like a color. I think it is really cool. So let's take a look at the row. So consider like constructing the Android user interface with Lego blocks. So with the row function, like you can stack the brick horizontally to build the row. So each brick represents a composable function. As in with the box, in box we stacked upon each other. So in row function, we are just like building horizontally. So row is an effective tool for creating horizontal layout since it is much like a horizontal linear layout in classic Android. So in a row, elements are positioned horizontally, as I said it before. So you can put any other composable function inside of a row, like in the box, text, images, buttons, other columns or rows. You can put it in them. So let's take a look at the code example. So here is the greetings tree function, which is another composable function, as we can see with the composable annotation here. So inside of it, we have defined and inside of the row, we have some modifiers again, padding and background. You can see we have the padding and we added the background here as a blue. And after that, as we can remember from the first example, um, we can see that we have a row scope here, which is similar to like a column scope or box scope. We have a row scope. And here we are just like giving the text, image, and button. And inside of it, it just stacked upon like horizontally. So first we added the text, and after that we added the image in the middle, and lastly we added the button in the right corner we can see, which is stacked upon horizontally. So the next one is column. Consider again like a Lego blocks. You are just like building upon vertically, which is we are calling it a column. So again, inside of the column, it can have like text, images, buttons, other columns or rows. So this can easily create complex UI structures by stacking your composables vertically. So we have some key features of column. So you can nest columns within each other to create more complex layouts, or you can customize the spacing between your composables, like using modifiers like vertical arrangement and vertical gap. So also column is a lightweight and efficient way to build UI too. So let's take a look at an example. So here as we can see the greetings to function, which is another composable function, as we can see it through the annotation. Inside of it, we have column. Again, it is the same as like the row, box, and text. The implementation is the same. And inside of the parentheses, we are giving the modifier here, which we are setting the padding, background color. And now in the first code block, we also saw that we have something called fill max width. So what is this fill max width? So in Composable, everything at the default set to wrap content. So if we want to change that, we can use dot fill options. So we use the fill max width also in the first one too. Sorry, we use the fill max size in that one, but we are using fill max width here. So we are filling the width of the screen. So it helps us to like fill the whole width. So inside of the brackets, also we have again our text, image, and buttons. So as you can see easily, like they're all stacked upon each other vertically. So the most important thing in here to understand the fill max width and also fill max size. So there is another example with the film exercise. We saw the film exercise in the first slide too. The film exercise helps us to fill the whole slide vertically. Film width helps us horizontally. Film exercise helps us vertically. If we don't set those, it automatically sets the wrap content in Jetpack Compose. So this is an important information to remember. We also have a cool feature we can use since the compose is basically a coding code. So as a scenario, so if we want to just create a whole page with these images and buttons repeatedly until we have 3 of them, so we can easily use a for loop for that. So if we use that, we couldn't find the exact amount, like how much of them fit inside of the screen. So we have lazy layouts for that. Let's take a look at the lazy layouts. So lazy layouts are a specific type of composable functions used in Jetpack Compose for displaying large datasets efficiently. So they are designed to only load and render the items when currently visible on the screen, optimizing performance and memory usage. It definitely helps with that. So here's how lazy layouts works. So instead of loading all the items at once when the user opens the screen, it, it instead of loading all the items at once, like lazy layouts only create and render the items that are visible in the screen. So as the user scrolls, the lazy layouts like automatically loads and displays additional items like as they become visible to the user. So this approach definitely improves like performance, especially if you are handling large data sets. So it definitely avoids like unnecessary calculations and rendering of items that are not even seen by the user. So lazy layouts use like various techniques to achieve this. So the first one is item catching. It catches previously rendered items to avoid recreating them when they become visible again. So prefetching, which helps the preload items that are expected to be visible soon. So it definitely helps with minimizing the delay when the user scrolls down. So the last one is the view recycling. Uh, it reuses existing views for different items, which definitely helps with reducing memory usage. So the benefits of it, as we talked before, like the improved performance with large data sets, minimize memory consumption compared to like normal layouts. Also, as we can see on the screen, like the lazy column displays item vertically in a scrolling list. Lazy row displays item in a scrolling list horizontally, and lazy grid displays item in a grid with multiple columns, which we'll take a look at the code examples right now. So let's take a look at our previous example and make it with a lazy column. So the last one we did with the color. So in here, like it is the same as defining columns and rows. Like first we initialize our lazy column, and after that we are giving our modifiers. So we also add the film size to see how it behaves in the screen, and we can see that it fills out all the screen. And after that, in the columns, we have something specific called items. You can see it here, which is works like a for loop. And after we initialize that, items ensures that only visible items are composed, which will help us improve the performance of the app. So the same behavior we have as in the recycler view before, but we can also have like lazy row and easily take a look at that too. So it is the same in here too. We just switch out the lazy row and use again items. And when the horizontally, when the user just like scroll it horizontally, we will now render items when the user saw that. So it is definitely an easy way to implement and easy way to use. So let's take a look at the example of a grid. So with lazy vertical grid, we are giving a fixed column size, which is, again, it is the same with implementation. We are just calling the lazy vertical grid in here, and we are just like giving the columns and again giving the modifier and using the items function here too. And inside the item function, we are adding the card elements. But the important thing is here, we are giving like grid cells, which is a fixed count, and we are setting that to 5. So as you can see it in here, we are going, our list is going like this. Like we have 1, 2, 3, 4, 5, and it is like going like this. So it helps us to create like 5 vertical columns. So you can use like simple grid layouts with this. You can easily implement that, and you can just like customize the code further by like changing the number of columns, the item layout, and the styling of the grid, and it has items. So the important thing is, and we didn't saw it before, like the card element. This is like creates a card like UI element in Compose, and we saw the items in the previous example too. So this function iterates through a list of items, as I said it before, and the vertical grid implementation is the same. But in here, we are giving a column. So let's take a look at it here. So with the lazy horizontal grid, we are giving a fixed row size here. So as you can see, we are not giving a column like a lazy vertical grid. We are giving a row here. So it is again a fixed size, fixed count, and the count is going like this right now. So 1, 2, 3, 5, 4, 4, 5. It is going like this. So it is going like this in here in lazy vertical grids. We are creating columns. With the lazy horizontal grid, we are creating rows. So the only difference is here is this, and it is definitely easy to implement. Again, the same code here, we only change the lazy horizontal grid and the row part. So let's take a look at the flow layout. Like what is flow layout? So in Jetpack Compose, flow layouts are composable functions that allow you to like arrange your children in a flowing manner. So this means that the children will automatically wrap around the next line when the container runs out of space. So what does that mean? So creating a multiple rows or columns definitely helps with that. So when you run out of space, it creates multiple rows or columns. So what are the key features of flow layout? First one is being a dynamic layout. As I said it before, if you run out of space, it creates like rows or columns. So it automatically flows to the next line on the base available space. It automatically flows to the next line. This is the dynamic layout means. So it is flexible, can be used to display a list of items of varying sizes. It is easy to use, like similar to display list of items that vary in sizes, and also like similar to row and column, but with automatic wrapping. Yes, definitely, definitely. It is definitely a less code and also easy to understand rather than XMLs. I think it is much more easy than XMLs. So it is lightweight, efficiently renders only the visible items. So flow layouts available in two forms. The first one is arranges children horizontally. It is similar to a row, but as I said before, it comes with the automatic wrapping. So the second one is flow column. It arranges children vertically, similar to a column, but with the automatic wrapping. So let's take a look at the code example. Again, with the flow layout, this composable like creates a flow layout and arranges children in a flexible way. So with the modifier, we set the layout width to fill maximum available space. The new thing we are seeing in here is main axis alignment type, which specifies how the children should be aligned horizontally. In this case, evenly spaced. So the second one is we are seeing newly cross-axis alignment keyword, which specifies how the children should be aligned vertically. So in this case, it is aligned centered. So we have something called also spacing in here, you can see, which will set the spacing between the children. So we know the items from before, and the items for each method is iterates through the list of items and creates a button for each item. And we all know what button is, creates that button, and with the item text, it is in the contents of it. The on-click is empty. So water break. So lastly, we have a constraint layout in the layouts. So with the constraint layout, like you can arrange composables on the screen in relation to one another, and you can use like several nested row, column, box, and other custom layout elements as an alternative. So when designing like larger layouts with more intricate alignment requirements, like constraint layout definitely comes in handy. So think about applying a constraint layout in the situation, like um, if you want to make your code more easy to understand, avoid like layering numerous columns and rows when arranging components on the screen, definitely consider using constraint layout. Or if you want to like arrange components in relations to one another or in like accordance with rules called like barrier or chains, you can definitely consider again using constraint layout. Or if you have like large and complicated layouts, as I said it before, definitely it is an easy way to build them because in the view system, like since like nested views were not as performant as flat view hierarchy, so constraint layouts comes in handy. So some of the key features of constraint layout is one of them is precise control. So what does that mean? So using the constraints to specify like each composable's precise location and size, you can easily do that. So the flexibility is the other one is with layered chains and constraints, like you can easily design complicated layouts and implement like a lot of like inside of it, you can implement a lot of things. So it can also help you to adapt your layout to various screen sizes and orientations with responsive design. And the last one is being a declarative. So using clear and comprehensive language to communicate your like layout restrictions. So it definitely comes in handy for that too. Let's take a look at a code example here. So here again, we have our modifier, and after that, we are creating our references for our composables. Inside of the constraint layout, we are having a button and text, which we are creating in here. And with the top to link to and start to link to helps us to like position our button and text view in the screen too. So, and the other one is if you want to use constraint layout, you need to add its dependency to your active Gradle files too. So let's get started with animation and transition. I think like this is one of the coolest things with the Jetpack Compose. It is so fun to experiment with, and I really love the animation and transitions. I added like this to the presentation after I finish the presentation because I think this is really cool and I wanted to just see this part of the Jetpack Compose too. This is really simple examples, but I wanted to give you like what's possible with a glimpse of that. So let's get started. We have two examples with animations and transitions. Let's get started with the first one. So in here, we are seeing that it is really easy to like a smooth way to like growing and shrinking the box with clicking the button. So this is the code blog, and let's dive in. So think of it like in this is grow. So think of it as a light switch. When the switch is off, like false, box is small. So when you flip the switch on true, the box smoothly grows larger. So the size variable is like the box actual size and the ever-changing size during the animation. So this code like creates a smooth way to dynamically changes the UI. So it is really cool thing. So let's take a look at like line by line how this does happening. So we know the column part of it. We talked it before. It is the same. We have like our modifiers, fill max size, like horizontal alignment, which sets the box in stand horizontally. And we have our button, and we have a spacer called which is in here. We have a spacer, and we have a box here. So it is the same as we saw it before. But the important thing is the first lines of this code. So this is really a new thing we will learn today. So let's get started. So we have something called var is grow. And after that, we have something called by remember mutable state of. So what does lines means? So this declares a mutable variable name, which is like is grow, and the var keyword, as we all know from Kotlin, like the value can change. So what by remember means? So this Kotlin like by keyword is used with a delegate. So it is using the remember composable function as a delegate to manage the state of is grow. So in Jetpack Compose, like remember is a composable function that helps you preserve the value of a variable across recomposition. So recomposition happens when UI needs to be updated, like when the data changes, UI updated. So remember ensures that with the remember keyword here ensures that like the value is retained and not reinitialized each time the composable function is called. So again, we have something called a mutable state of, which we are giving the value false default. So this is a lambda function that initializes the mutable state object. So this creates a mutable state object and holds the value, which is in this case, we are setting false, and notifies compose when the value changes. So mutable state is a core concept for state management in Compose, as I cited in the beginning, if you remember. So it is a wrapper around the value that automatically triggers recomposition when the value is modified. So the initial value is the grow is false. But this means that at start that our animated element will be small. Let's take a look at the example. Like when actually it first open, like it is small. So because our mutable state for the is grow is false, but when we click the button, it will again shrink. So this is a great way to understand like the mutable state object. So in summary, these lines create a state variable is grow that start as a false and remember its value across recomposition, which we called recomposition. The changes to is grow will trigger recomposition and allowing us to update the UI. So I'm sorry. Okay, so in summary, as I said it before, the line creates a state variable is grow that start as false, which we are giving it a false, and remember it is value across recomposition. So changes to is grow will trigger recomposition. So when we change the is grow, it will trigger recomposition and change the UI as we can see it in here. When we click the button, it shrinks, grows or smalls. So grows or shrink. Sorry. So let's take a look at the second line, which is a wall box size. So this declares the read-only variable name because we are using wall. This variable holds the current animated size value. So we have something called like animate DPS state. Let's understand that. But this time we are using animate DPS state as our function, like a remember function here. So this is again a composable function from Jetpack Compose animation API. So it is designed to animate a DP, which is called density independent pixel value. It smoothly transitions the value from its current state to new target value over time. So which we have in here, like a target value and animation spec, which is our like the duration, how the animation happens. So let's take a look at it, like what target value is. So in the target value line, we have something called like box size. And if the box size is um, 200 dp, and else we have like a 100 dp. So this parameter specifies the end value of the animation. So the animate dp as state function will animate the value towards this target. So if grow is true, like 200 dp, else if it is false, yeah, that means so it will 100. So this is a coding if else expression, as we all know. So it checks the value of is grow. So again, with the target value, again, if is grow is false, the target value will be 100, the smaller size. After that, we have something called animation spec. So this parameter is used to configure the animation itself, like how long it takes, how it is accelerates, etc. So we will use a twin in the second example too. In twin, we are setting to 1000 millisecond, which will be 1 second. So twin is predefined animation specification, again, predefined in Jetpack Compose, which helps us to create like a simple animation that smoothly changes values over a specific duration. So again, we are giving the duration millers inside of the twin, and this sets the animation duration to 1 second. So again, we can give a label here too, but I just gave it to empty. So it creates an animated DP value that's represented by the size variable, first of all. The second thing is it sets the animation target based on the value of isGrow. So if it is isGrow is true, it animated towards 200 dp. Otherwise, it animates 100 dp. So it configures the animation to take 1 second only because we are giving it 1 second here in the duration mills. So you can change all of it and just like experiment it with it, how it is working. So it is definitely a cool thing to learn, in my opinion. So let's take a look at another example. I know we are also having a little bit of time problem here. So yeah, in the second example, we are seeing again like the by remember keyword, and now we have something called animated visibility. So the purpose for this composable is to design to animate the visibility, like the appearance and disappearance of its content based on the visible state. So it is like a special container for composables, like where you can specify how they should enter and exit the screen. Like we will do something like this for like maybe how can I say, like in the presentation deck with the presentations, we will do something like this, like appear or disappear with the content before. So it is a really cool thing. Again, you can show and hide the box in this example. So let's take a look at it a little more in depth. So what is the core functionality with the animated visibility here? So it does two primary things. So one is conditional visibility. It determines like whether its content is currently visible in the UI on the visible parameter, as we can see it in here, which is getting this value from here with the by remember state. So with the is visible, this is the required parameter with the animated visibility. It's a Boolean value, which is dictates like whether the content within the animated visibility should be visible or not. So as we can see again in the beginning of it, like this is a state variable with is visible. So it is created using the remember, as we can see in the previous example. So this is why it's typically a variable, because like when the is visible is true, the content will be shown, and when the is visible is false, content will be hidden. So when the value of is visible changes, like the animated visibility recognizes this change and triggers the appropriate enter or exit animation, as we can see it in here. With the enter animation, we have something called fade in, and we are giving like the animation spec here, and we know even from the previous example, we are giving our like the duration millis in here too, which is 1 second in this example too. So we have something called like fade in and fade out. For the enter, we have faded. So this is again a built-in a function, like enter transition function in Jetpack Compose. It creates a fade in effect, like fading. As we can see it in the screen, it is like fading. So where the compose gradually becomes opaque. So starting from being completely transparent. So again, we have a fade out, which is like, how can I say, it is completely hidden. Like when the compose gradually like becomes transparent, when it's fading out, it is completely hidden in the screen. So we cannot see it. So it is called fade out function, which is again same. It is like a built-in function in Jetpack Compose. The animation spec is how will animation happen, which is in this case, flow of time is set to 1 second. And the twin is a really important thing to learn here with the animations. We can see the same example from the previous one too. Here we also have twin here when we are giving the animation time, we are using twin again. So in here we are using twin again too. So, but the animated visibility have something called enter, exit parameters you can give. So it is a great way to start, but you can build upon that knowledge a little bit more in the future if you want to learn more about that. So lastly, let's take a look at what is material design in Compose. So maybe you heard of it before, maybe you didn't heard of it. So material design is like Google created material design, which is a complete design framework that offers resources and principles for making aesthetically pleasing, useful, and accessible user interfaces. I'm sorry. I'm sorry. Um, what can I say? Okay, so let's take it, take it from the beginning. So with the material design in Compose, so Google created the material design, which is a complete design framework that offers resources and principles like making more aesthetically pleasing and accessible. Actually, the main thing is being more accessible with the user interfaces with the material design. So it is simple to include material design ideas into our apps using Jetpack Compose. And here is like what material design in Compose offers. The first one is consistent visual language. So what does that mean? So components, a range of ready-made composable functions like buttons, cards, text fields, and more, like all adhering to material design principles. As we can see it in the previous examples, like it comes with like predefined functions with the box, like the layouts and everything. It is definitely easy to implement and easy to use. So animations and motions, we saw the animations. We saw a real glimpse of it. It is really a deep presentation. Like it should desire a whole presentation for the animations. But I show you like a little bit of a glimpse of it. But animations are really cool, and it definitely creates like a natural, delightful interactions using like pre-built animation and motion guidelines, which is as we saw with the examples, like they definitely have everything ready, like the fade out, fade in, like everything is ready for you to use and create animations. So it is definitely accessible for developers too, in my opinion. So usability and accessibility is the second thing, which helps us to like organize your content in a way that is clear, scannable, and easy to understand with the intuitive layouts. And also the second one is accessibility, and designing your UI is to be usable by everyone, like regardless of their abilities. And the last one is the internalization, which will mean that like the supporting different languages and also cultural context. So the third one is flexibility and customization with the material design, which compose everything. So build your UI like entirely using composable functions, which definitely helps you to allowing for rich customizations with the modifiers and also like the other stuff and help you with the dynamic behavior too. The second one is the extensible themes, customizable themes to create like a unique look and feel for your app. And the third one is interoperability, using material design like alongside other UI libraries and custom components too. So some of the benefits is faster development, which definitely it is the same benefit with the Jetpack Compose, in my opinion, like quickly build like beautiful functional UIs and ready-made components and themes. And the second one is a consistent experience. Like the material design ensures that your apps follows Google's design guidelines for familiar and intuitive user experience for every user. So the third one is accessibility, which is really important with the creating an application, uh, making sure that your app is accessible to a wider audience by like adhering to accessibility best practices, which can include like maybe read a loud function to add to your application, something like that. And the last one is an improved performance. So compose and material design are optimized for performance. As we saw with the like the lazy layouts, like the lazy row, lazy column things, it focuses on the performance a lot for the large data sets. So compose and material design are optimized for performance. And also helps us to create faster UIs too. So we also have something called dynamic color, which means that like algorithm drives custom colors from like a user's wallpaper to be applied to their apps and system UI. So this color palette is used as a starting point to generate light and dark color schemes. So whatever the user are using, like dark mode or light mode. So in the picture, we are seeing like a replace sample app dynamic theming from wallpaper left and the default app theming from in the right. So dynamic color is available only for like Android 12 and above. So if dynamic color is available, you can set a dynamic color scheme. If not, you should fall back and start using a custom light or dark color scheme too. I think it is important to create both of them because most of the users are using in the dark mode these days. So it's nice to have that too in the app. I'm sorry. So color scheme provides builder functions to create dynamic light and dark color schemes. So let's take a look at a code example. You can access material theme colors in your app via material theme.color scheme. As you can see it in the example, I just set the card's background color with the material theme easily. I just accessed it and like this and use it. So it is easy to use definitely. So each color role can be used in a variety of places depending on the component state, prominence, or emphasis. So the first one is primary, which is the base color. So used for like main components, like prominent buttons, active states, and the tint of the elevated surfaces. So the secondary key color is used for less prominent components in the UI, like such as filter chips, and expand to the opportunity for like color expression. And the third one is the tertiary key color, which is used to drive the roles of constructing accents that can be used to balance primary and secondary colors or bring like enhanced attention to an element. So thank you so much. I talked a lot and my throat is hurting right now. So you can contact me on LinkedIn. I used the informations from the official Android side of Google, and you can also like check the Google site. They have like great code labs and everything. You can check. And as I said it in the beginning, if you have any other question, please contact me on LinkedIn and ask me your questions. I will happy to answer. And other than that, thank you for being here. I hope you learned some Jetpack Compose today and you get interested in Jetpack Compose because I'm a really advocating for Jetpack Compose and I love Jetpack Compose so much. So if you learn a little bit about Jetpack Compose today, I will be so happy. So thank you everyone for joining.
So I just want to give you a last minute shout out. Thank you so much, Selen, for our amazing sessions. You gave a lot of knowledge, stuff that I didn't even realize, and I'm not even a designer. So thank you so much for the session. It was very informative, and you dropped a lot of hints and a lot of tips. And just in case anyone who's watching the recording of this is on our YouTube channel, so please follow us there if you want to see more of Selen's insight. You can also connect with her on LinkedIn, as she just said. And please, if you have any questions, she's inviting you to ask her questions. That shows us how much work that this session would be. So please, for her inbox with just praise, the love, all that she deserves, and any questions you have. But we want to thank you so much for taking an hour at your day to give it to us. It was much appreciated, and it was an amazing session.
Thank you so much. Thanks so much. It was my pleasure. And it is really a good thing that you are doing the sessions too. So happy to support, happy to be here.
We're lovely, and we hope we can get you for a couple of more. So now,
Yeah, I will love that.
so now we're at time, everybody. But thank you so much for joining us. And don't forget, we have 2 more sessions tonight, one at 6 p.m. and one at 8 p.m. Looking forward to seeing you there.
Take care, everyone. Bye bye. Thank you, Dom.
No problem.